Welcome to Pure 2, Chapter 10.3, where we continue our chapter on approximating roots. So this lesson, we're looking into Newton-Raphson method, essentially just a formula, okay, about something to do with Newton. Again, yes. Um, in addition to iteration, we could also use Newton-Raphson formula to approximate the numerical value of the roots y equals f of x when f of x equals 0. So the Newton-Raphson formula is x of n plus 1 equal x of n minus f of xn over f dash xn. F dash means the derivative. So actually, this is given in formula booklet. This is given in the formula booklet, not Facebook. Okay, I believe the audience of this video should be quite young, so you don't know what Facebook is, which makes sense. The formula will fail when, okay, when xn is the turning point. Now you can wonder why. Okay, what happened to xn? When xn is turning point, okay, then the f dash xn will equal 0. And in this fraction, if you have it over 0, it will fail. Okay, you can't have denominator equal 0. Okay, that's why. Okay, so it's quite a simple thing to explain really. Given x equals cos x, use Newton-Raphson procedure 3 times to find a third approximation to alpha with x naught equals 0.5. So first of all, what we need to do is we need to rearrange the equation into make it equal 0. So we're going to do x minus cos x equals 0. So therefore, f of x equal x minus cos x. And we're also going to differentiate. So differentiate once, which is 1 minus differentiate cos x is negative sine x, is it? Sine x, just sine x. Differentiate negative cos x is, hang on, x minus cos x. Sine cos minus sine minus cos. Differentiate minus cos, you get sine. So 1 plus sine x, sorry. 1 plus sine x. I get confused in here, not because I can't do maths, I'm teaching you in here, but it's more like in my notes, I make the other way around. I make cos x minus x equals 0, which is perfectly fine. So, but in here, I do the other way around. Anyway, so f dash x equals 1 plus sine x. So what we should do in here is simply we use a formula. So let me write the formula again. The formula, the Newton-Raphson is x of n plus 1 equals xn minus f of xn over f dash xn. Right, so what we're doing here is, so we want to find x1, so x1 equals x0 minus f of x0 over f dash x0. So what we can do is we can put in a calculator, essentially equals, what's x0? X0 is 0.5, so 0.5 minus f of x0. So the function, the f of x0 is this one, the x minus cos x. So it'll be 0.5 minus cos 0.5. We'll replace x with 0.5. And f dash mean we substitute the x equals 0.5 into the derivative. 1 plus sine 0.5. Okay. And then put in the calculator, I believe you should get Um, I believe the question it should be in radians because the degrees will be too small. Okay, make sure calculating radians. Okay, you should get 0.755. Okay, and then we'll do it again. Okay, so x2. Now, so what we can do in here is now how can you speed up the process instead of putting it into calculate each time? What can we do? We can replace this with the answer button. Replace everything I highlighted in yellow with the answer button. So what we'll do is let me show you. So I'll put 0.5 in the calculator, okay, equal. So that's my answer button. And I'll do answer minus a fraction. Okay, so answer minus cos answer over 1 plus sine answer. Actually, I need to change my calculator into radians. Radians. That's 0.755, my first answer. Equal 0.7391. That's the second root at x2. X3, do it once more, 0.739. So 7391. Oops. Okay, and that's it really. So that's how you have to do the question. Okay, if you're happy with this, okay, essentially let me run through again. First of all, find f of x. Next, find the derivative, and then use the formula and substitute x0 into the formula. Whenever you see x, you sub in the function f of x in the numerator and sub in the derivative in the denominator. And in the calculator, makes x not equal in the answer, make it into the answer button. And then every time you see x0 in the formula, you replace it with the answer button. Okay, right. So let's see if you can do the next one. Okay, there are two practices, but have a go at the first one and then see if you can get it done. Okay, pause the video, have a go at the question. So they want you to do it once, just do it once to obtain the second approximation. Do it once. Okay, do it once. Pause the video, have a go at the question. When you're ready for the answer, you can press play. Right, so here are the answers. If you got it right, well done. That's it. Okay. You can move on to the next one more, I think. Yes, there's one more. But if you don't, I'm gonna go through step by step with you how to do the first one in here. So we know that's f of x. So we've got f of x. We need let me write f of x. I just got a weird habit. I just like to rewrite the question. And you know what? And what's more weird is sometimes when I copy the wrong question, I end up doing the whole question wrong. So don't be like me. So differentiate once, you get 2x cubed minus 3x squared plus 1. Okay, so the Newton-Raphson formula tells me to do xn plus 1 equals to xn minus f of xn over f dash xn. So what I'll do is I'll put in the calculator. So I was told minus 1.5 as the first root, so minus 1.5 minus first root. Okay, so let's do it. So xn means answer minus a fraction. Substitute the function f of x in the numerator. So it's a half times x, which is answer to the power 4, minus answer cubed plus answer minus 3. For denominator, it's 2 times answer cubed because substitute derivative, and with x being with every time you see x, you replace it with the answer button. Minus 3 times answer squared plus 1. Finger cross is 1.3875. But the question wants you to do two decimal places, so it's minus 1.39. So x1 is minus 1.3875, which is minus 1.39. Okay, now if you're happy with this, pause the video, have a go at this one again. If you got it wrong, got the first one wrong, you should get you should get 1.384. The question wants you to use it once again to three decimal places. So this is a calculated display you should have. So you should press 1.4, and then this is a display that you should have in the calculator. You check it one by one. Okay, and that's it. Right, moving on. Okay, next practice. Again, pause the video, have a go at the question. When you're ready for the answer, you can press play. Here's the answer. Part A, because x equals p is turning point. Okay, we mentioned that in the notes. Part B, you substitute, differentiate once, substitute in the calculator. They want you to do it twice, so make sure you put it in the calculator carefully. You should get 1.85867 the first one, 1.856 the second one. And then part C, by considering change of sign, so you use upper bound, lower bound method. Okay, so 555, 1.8555, 1.8565, and so sign changes, there's a root, and therefore there's a root which equals 1.856 and round to 3 decimal places. Okay, and that's it for 10.3 Newton-Raphson. Sounds difficult thing, but actually it's just formula.